Hello and welcome to this lesson on rational numbers as fractions and decimals. So our job in this lesson is going to be to show that a rational number can be written as a fraction and to show that those fractions always have terminating or repeating decimals. We can see the essential question says, how do I convert rational numbers into fractions and decimals? And we talked about rational numbers in the previous lesson as well. We learned what they are. Did you know that every number can be written as a decimal, but not every number can be written as a fraction? In most cases, if you evaluate an expression or do the math, it will convert a number to a decimal. And that means, like, if you have a square root of 42, if you would actually square root that, like type it into a calculator, it will give you a decimal. If you would have 3/4, that is just a division. 3 divided by 4. If I do 3 divided by 4, it gives me a decimal. That's what it means by if you just do the math, it will convert it into a decimal. Hey, there's no new vocabulary. Love it. Moving on. So the first skill here is we want to be able to write each of these rational numbers. Everything we're going to see in this lesson is a rational number. We want to write each of these rational numbers as fractions. Okay, so starting with letter A, nice and easy. The way you take any whole number and write it as a fraction is you simply put it over 1. That's it. 8 over 1. That works with any whole number. Letter B. Now that is a terminating decimal. The proper official way to read that number is -3 and 56 hundredths. Now if you know how to properly read a decimal, the way you read the decimal and read the fraction is identical. -3 and 56 hundredths. That is what it would be as a decimal, or as a fraction, at least to start. And then we would simplify that fraction. Now, if you don't know how I got that, well, the -3 is just going to be your whole number -3. The part after the decimal is going to be your numerator. And because this is a terminating decimal, because it stops right here, I know my denominator is going to be a power of 10. It's either going to be a 10 or 100 or 1,000. It's a 1 followed by a whole bunch of zeros. And how do we know which one of these it is? Well, 56 has 2 digits, so I picked the one that has 2 zeros. That will pretty much always work. And then we could simplify that fraction. So 56 fraction 100. Get out of the fraction, simp, enter. And that little arrow shows me I can simplify some more. Simp, enter. And there's no little down arrow, but just to double check it, nope. So that would be -3 and 14 out of 25 is it as a simplest form. Now, technically, I guess, this is not officially a fraction. This is a mixed number. And I didn't even have to simplify it because it just said show that it's a rational number by writing it as a fraction. I would accept -3 and 56 over 100. Fine. But some people may not. So the way you would change this number into a fraction, it would be an improper fraction, is, if you remember from before, you would multiply the denominator by the whole number, which would be 300, and then you add the numerator, so 356. The denominator stays the same, and just don't forget about your negative sign. That's what it would officially be as a fraction. One number over another number. And we can see that it is a rational number because we were able to do it. Now, letter C is the square root of 9. If you don't know what the value of that number is, you can calculate it. Hey, that's just 3. And so then as a fraction, that'd be 3 over 1. Write each rational number as a fraction. Check, check, check. Okay, here's a couple for you to try. So go ahead and pause the video, try these two on your own. When you're ready to continue, hit play, and we will go through them together. All right, first one. 9 and 3 over 10, because it's a terminating decimal, the denominator's out of tens, and the way you know how many zeros, do I have my thing up there? Nope, I erased it. It's gonna be either 10 or 100 or 1,000 or whatever. Because there's one digit after the decimal, it is in the tenths place. And then as an official fraction, that would be 93 out of 10. 10 times 9 is 90 plus 3. So that's a multiply. So 93 out of 10 is the official fraction. Letter E. So that says 2 times the square root of 4. The square root of 4 is going to be 2. So 2 times 2 is 4. As a fraction, that's just 4 over 1. That wasn't too bad. Now, what about the other way? Or, no, it's the same way, but now we have repeating decimals. We want to write each of these repeating decimals as fractions. Now this is very much what like we were doing up above. The whole number is going to stay the whole number. The junk after the decimal is going to go up top. The difference is going to be, remember how before this denominator was a 10 or 100 or 1,000 or a 10,000? It's just a 1 followed by a bunch of zeros. That's what happens if this was a terminating decimal. But because it's a repeating decimal, the only difference is instead of it being out of a power of 10, it's instead going to be out of 9 or 99 or 999 or 9,999. It's out of a bunch of 9s. And the way you know which one it is the same trick as before. There's 2 numbers being repeated, so you pick the one that's 2 digits long. So that is what it would be as a mixed number. And I'm okay leaving it as a mixed number. I don't need to change them to improper fractions. This is, for most people, good enough to show that this is a fraction, because there's no decimals, there's no weird things in here. It's a whole number followed by a fraction, and that is fine. At least in my book it is. Letter B. I'm going to convert this into a fraction. So my whole number is a 0, so I don't really need to put a whole number 0. You can if you want, if it makes it feel good. The junk after the decimal is a 4. He goes up top. And in the denominator, because this is a repeating decimal, it's going to be out of 9s. How many 9s? Well, there's one number being repeated, so 1 9 goes down below. And if you check it on your calculator, 4 fraction 9, and if I convert it, 0.444444, just like that. If I go back to the other one, and I put in 1 and 29 over 99, oh man, 1 and 29 over 99. There we go. We got it. I do a little switcheroo. 1.29292929. The 3 is because your calculator rounds. All right, letter C. This is probably the last of these that I'm going to do for you. And hopefully you're kind of recognizing the pattern here. This is going to be my whole number, -6. The numerator is going to be the junk that's being repeated, 366. The denominator, because this is a repeating decimal, the bar. Because it's being repeated, it's out of 9s. How many 9s? Well, there's 3 digits being repeated, so I need 3 9s on the bottom. And then we would simplify if we can, but for now, we've shown that this can be written as a fraction, and that was our goal. We don't need to simplify. I don't need to change it to an improper fraction unless the question specifically asks for that. So I would like you to pause the video. I would like you to try these two, and when you're ready to continue, hit play, and we will go through it together. All right, so you should have got -2 and 7/9. There's my whole number, there's my numerator, there's one number being repeated, so I get 1 9 in the denominator. Boom, that's it. You should get 12 and 320 over 999. And you could always try to simplify the fraction if you wanted. This does simplify, I can see. I can divide top and bottom by 3. No? Oh, no, I lied. I guess it doesn't simplify. So that would be done. So that's how you change a decimal to a fraction. Now, your calculator also has this switcheroo button. So if I was doing this exact same problem, 12 point, I cannot just put 320 and switcheroo because it just thinks it's 320. With this being a repeated decimal, what we would need to do instead would be 12.320, 320, 320, 320, 320, 320, 320. Fill your whole screen with 3 2 0s. Now, if we use switcheroo, the calculator knows that it's a repeated decimal. And look at it. Look exactly what it gave us. -2.777777777777777777. I'm using the keyboard because it's a little bit easier than typing it. Switcheroo equals -2 and 7/9. So your calculator has the ability to do this as well. But it's also good to do by hand. Be able to do it by hand at least. Have the ability to do it by hand. Now we're going to do the reverse of that. We're going to change our fractions as decimals. For each rational number, show its decimal expansion. Round answers to the nearest thousandths. And a lot of this is going to be typing into the calculator. Really, that's like what that hint was at the beginning of the lesson, that if you just kind of like evaluate the expression, it turns it into a decimal. If I take 9 divided by 3, because that's what this says, 9 divide 3, it's going to give me 3. Technically, you could call that a decimal. If you don't like it, you can put a 0.0, but you don't really need it. But 3.0 is what it would be as a decimal. 1 and 2/9. Now, I don't even need a calculator for this because I know this is my whole number, 1 point. I know this pattern, this over 9. That's what we were just talking about. That's going to be a repeating decimal. So what's being repeated? 2. That is 1 and 0.2222222222222. 2 ninths. 22222222222. Okay? It's okay to use your head. You don't always have to use the calculator. Even though the calculator can do it for us. This one. I know the square root of 16 is 4. Square root of 16. 4. I know -3 times 4 is -12. So we could leave it like that, technically speaking. If you wanted to put your little decimal 0.0, you can do that too. Oh, I guess I should go back and read the directions because it does say round answers to the nearest thousandths. So technically that's rounded to the nearest thousandths because it's all zeros. That's rounded to the nearest thousandths, but my letter B, I didn't do that. 2, 2, 2. There we go. To the nearest thousandths is the third number after the decimal. The decimal places after decimal is you got your tenths, your hundredths, and your thousandths. So if I'm rounding to the nearest thousandths, I'm rounding to this third digit. So I've rounded my answer to the nearest thousandths now. All right, and here are two for you to try. Go ahead and pause the video, try these two on your own, and when you're ready to continue, hit play, and we'll go through them together. Now, there's no real trick to this one, because this is not something where, like, the bottom, if this was a 99, I would do 0.12121212. But if it's 19, we can't really do that. So our only real trick is I would divide it. That's what I would do. Or put in 12 fraction 19 and hit the convert button, or do fraction to decimal up here. So 0.6, oh, I should probably write it, 0.63157, ... Now, if we're rounding to the nearest thousandths, we've got tenths, hundredths, thousandths. So this one will be our last digit when we round. We have to decide if this one is going to round up or stay the same. And hopefully in your head you know that that one will, round up. Because his buddy next door, this 5, is a 5 or bigger. If it's a 5 or bigger, then it rounds him up. If this was a 4 or less, the 1 would stay the same. So this, in pink, magenta color, will be our final answer. That is what it is as a decimal, rounded to the nearest thousandths. Letter E. I could do a bunch of this in my head. Things I know. I know the top square root of 9 is 3. I can see that this is a 99. That means I know that there are going to be 2 digits that are being repeated, because you see I've got 99, and that was the thing. Like, that this showed you how many digits were being repeated. Now you might be looking at that going, but wait a second. I've only got 1 digit up top. How can 2 digits being repeated? Well, the number 3, if you'd write 3 as a 2-digit number, would be 03. This is going to be the decimal, 03030303. 3 divided by 99 is 03030303. There are 2 digits being repeated, so I wrote 3 as a 2-digit number. Obviously, if we put this 0 on the other side, that's not the number 3 anymore. That's the number 30. That's why it has to be over here. And if we take our number and round it to the nearest thousandths, you can see that we don't need these extra digits. And if I undelete here for a second, rounded to the nearest thousandths is here. This 0 will not round up because his buddy next door, the one in the 10,000ths place, is not a 5 or bigger. So that is our final answer, rounded to the nearest thousandths. Problem solving. We're on the applications already. James has a cake recipe that calls for 1/3 cups of flour. What would this number be when written as a decimal? Okay, that's a pretty straightforward problem. Just what is 1/3 as a decimal? So 1/3, calculator if we need to, brain if you don't. I mean, here's what happens in my brain. 1/3 is the same thing as 3/9, which I know is a repeating decimal of 0.3 repeated. That is what went through my brain to get from here to here. Or you might just know, because 1/3 is a fairly common fraction. You probably know what 1/2, 1/3, 1/4, and 1/5 are, all as decimals. 0.5, 0.3 repeated, 0.25, 0.2. Those are very common fractions to decimals that you'll see a lot of. percentages. If something is 25% off, it means it's 1/4 off. Stuff like that. You also have your handy dandy calculator where you could just do 1 fraction 3 and then switcheroo. And there you have it. Example 4 says Beth is trying to make a new belt from a piece of fabric. Her waist is 32.25 inches. What is Beth's waist in inches as a fraction? So we want this number, right? We want this number as a fraction. And again, this is one of those very common decimals I had up there I just erased a second ago. I should really stop erasing those things. They're kind of useful. But things I can do. I can still convert this. I know that this would be my whole number, 32. I know the stuff after the decimal is the numerator. And I know because this decimal stops, it is not a repeating decimal. I don't have the bar up here. I know that it will be, the denominator, a power of 10. 10, 100, 1,000, 10,000, and farther. And how do I know which one it is? Well, there's 2 numbers up top. So I pick the 10 to the second power. I picked the one with 2 zeros after it. 100. You also may know that this last digit, this 5, is in the hundredths place, which is why, another reason why, we put in a 100 here. Either way, that's our answer. And technically, I guess I need my unit of inches. Boom. Do I need a unit in the last one? 0.3 cups of flour. Letter C. Sam has a square yard. Okay, square yard. Here we are. With an area of 49 feet squared. To find out how much fence he would need to install to go around the perimeter of his yard, he can evaluate the expression, this. He can evaluate 4 square roots of 49. How many feet of fence would he need? Okay, so that the wording there is a little hard. That's the part that makes this a hard problem. The math actually is very easy. Let's read it again. To find out how much fence he would need to install to go around the perimeter of his yard, he can evaluate this expression. Okay, so if we evaluate this, if I find out what this is as a number, that's how much fence he needs. So how many feet of fence does he need? I don't know. Let's do this math. So that is just 4 times by the square root of 49 is 7. 49 is a perfect square. It's 7 times 7. So that's just 28. This guy needs 28 feet of fence. He has a very, very tiny yard. It's only 7 feet on each side. That's a super tiny yard. Letter D. It says, during gym class, students were asked to measure their heights. Don measured his height to be 62 7/12 inches tall. Jim measured his height to be 62.6 inches tall. The boys are trying to see who is taller. Write both measurements as fractions. Write both measurements as decimals, and who is taller. So take a minute or so, pause the video, and I'm not quite sure what this little bar is. I'm wondering if this was supposed to be over top of the 6, but we can ignore it for now. We'll just do the numbers like we have them here. So write both of their measurements as fractions, both their measurements as decimals, and then figure out who is taller. Pause the video. When you're ready to continue, hit play, and we'll go through it together. All right, so let's see here. We've got Dawn and Jim. I'm making a little chart here to help me organize all my thoughts. I'm going to write their things as fractions and as decimals. I probably didn't need lines quite that big. All right, so things we know. Don measures height to be 62 and 7/12. Well, that is a fraction already. 62 and 7/12. Jim measures height to be 62.6. That's a decimal. 62.6. So all I need to figure out is these other two measurements, and then eventually figure out who is taller. So to change this fraction to a decimal, I'm going to figure out what 7/12 is as a decimal, because I know it's going to be 62 point something. That's my whole number. That's my whole number. But 7/12, 7 divided by 12, or you could do 7 fraction 12 and then convert, is 0.583 repeated. 0.583 repeated. Okay, Jim, this is Jim's measurement as a decimal. To change that into a fraction, I know it's going to be 62 and 6 over something, because that's my numerator. The stuff after the decimal is the numerator. So I have to decide down here, what number do I put? Do I need a 10, a 9, something else? Well, it's going to be a 10, because this is a terminating decimal. We need a 10 down here. Now, who's taller? We are definitely not looking at fractions. To compare fractions is a huge pain, because you have to have common denominators, which means rewriting fractions, and it's a mess. But to compare decimals, it's very easy. You look at the digits one digit at a time. So my whole number is the same, 62, 62. I look at the next digit over, 5 versus 6. Which one's bigger? Well, 6 is bigger, which means Jim is taller. Jim is taller. There we go. We wrote them both as fractions, both as decimals, and we figured out that Jim is the taller one. I believe this is our last question. Yes, it is. Which rational number below is closest to the value of 45/8? I want you to try that one. Pause the video, try this problem, see what you can come up with, and then when you're ready, continue, hit play, and we'll go through it together. All right, so I'm going to start changing each of these to decimals. That's kind of the best way to compare numbers. We saw that up above as well in the previous problem. So 49, square root of 49, that's just plain old the number 7. 3 times the square root of 9. I know the square root of 9 is 3. Square root of 9 is 3. So this really becomes just 3 times 3, which is 9. I already have letter D as a decimal, 5.9 repeated. If you want to, you can add a few more 9s in there just to make sure you're understanding the problem. And I know what that is as a decimal. 1/2 is a very common decimal. That's 5.5. Now these numbers are kind of all over the place. I've got a 7, a 9, a 5.5, a 5.99999. So we want to know which one is the closest to the value of this. I don't even know what this is yet. I should probably convert him too. 45 divided by 8, or fraction and then convert. That is 5.625. So I think we can all agree that letters A and B are very wrong, because the 5.9 or 5.5 will definitely be closer than 7 or 9. So it's definitely not letter A, it's definitely not letter B. But how do we figure out which one's closer? Well, the actual math we would do is a difference. We want to know, well, what's the difference between these two numbers? That's a subtraction. If I took 5.6, ooh, that's not a 6, 625 minus 5.5, I'm going to get a difference of 0.125. That's how far apart these numbers are. They're 0.125 apart, which is very small. If I do the same thing here, 5.99999 minus 5.625, I would get, well, 9,947.3.0. All right, so these numbers are 0.374999999 apart. Well, letter C is closer. Its difference is smaller. The difference between the two numbers is not as big. So that's the one that's closest to 5.625. Summary. What types of decimals can be turned into fractions? Take a second, put down a thought, hit play when you're ready to continue. What types of decimals can be turned into fractions? And the answer is terminating decimals and repeating decimals. All right, so quick little recap of the lesson. So we'll start back at the top. Zoom, 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 zoom. All right, so things we did. We learned that to turn any number into a fraction, to a decimal, a lot of times you just, start over. To turn a decimal into a fraction, starting with a terminating decimal, you put it over a power of 10. 10, 100, 1,000. We learned that whole numbers can be changed into fractions by simply putting it over 1. Terminating decimal over 10, whole number over 1. We learned repeating decimals can be changed into fractions by putting the part that's being repeated over a bunch of 9s. And we learned the number of 9s is the number of digits that's being repeated. So 2 numbers being repeated, 2 9s on the bottom. 1 digit being repeated, 1 9 on the bottom. 3 digits being repeated, 3 9s on the bottom. More. We learned to change fractions to decimals by dividing, or using our brains, square rooting, using our calculator, dividing using the calculator, simplifying using our brains and the calculator. And then we just had some application problems that kind of rounded out the same types of problems. Changing fractions to decimals and decimals to fractions, evaluating an expression, changing fractions to decimals and decimals to fractions again, and finally figuring out which one of these has the closest value, and we learned to do that. You find a difference, which is a subtraction. Thank you for watching the lesson. Until next time, toodles.